We're going to talk about the first derivative test. The first derivative test is a test that helps me figure out where a graph is increasing, where a graph is decreasing, and it also helps me figure out where any maximums and minimums of an equation are located. So, basically some rules about the first derivative test. F of x is increasing where the first derivative is positive. I think that makes sense because the first derivative shows you the slopes, and where the slope is positive should be where f of x would be increasing. F of x would be decreasing where f prime of x is negative. Again, that should make sense. Another thing that it's important is f of x has a max where f prime of x changes positive to negative. At that place, the derivative may be 0 or undefined, but the derivative does have to change from positive to negative in order for that to occur. And if you think about increasing to decreasing, that makes sense that up at that place where it would change, that there would be a maximum. Similarly, f of x has a minimum where f prime of x changes negative to positive. The graph would look similar to that. The graph would be decreasing and then increasing, and then there would be a minimum there. The derivative could be undefined instead of 0 with those two places because it could be a sharp point, but either way it would still be a max or a min. So let's look at some examples. Let's say that we have f of x equals x to the third minus 3/2 x squared. And I'm trying to find out things about increasing and decreasing and maxes and mins. So first thing I'm going to do is I'm going to find the derivative, which is 3x squared minus 3x, because negative 3/2 times 2 would be negative 3. I'm going to set that equal to 0 because I need my critical points. My critical points are possible maxes and mins. So let's just find those. Factor out a 3x. And it looks like we have x equals 0 and x equals 1. Easiest thing that I think that we're going to do here is we're going to make a number line. Okay? And we're going to put our critical points on the number line. Right? And then we're going to test every little interval by using the derivative. So we're going to use the derivative and we're going to test each little interval. So we're going to come up here and pick some values. Pick a value less than 0. So pick something here. Pick something between 0 and 1, and pick something bigger than 1. And we're going to plug it into the derivative to see if you get positive or negative. So if I pick like negative 1, 3 times negative 1 squared is positive 3. Minus 3 times negative 1 is another positive, so we would have positive right there. And any value you pick in that interval will always come up the same unless you've chosen the wrong critical points. So then let's say I pick maybe a half between 0 and 1. So 3 times a half squared would be 3/4 minus 3 times a half. Well, that comes out to be negative, so I'm going to put a negative here. And then pick something bigger than 1. I usually just pick a really big number. Plug it in for x, you will get positive there. So what this tells me is that from negative infinity to 0 and from 1 to infinity, f of x is increasing because this is showing me places where the derivative is positive. It also shows me that between 0 and 1, f of x is decreasing. Now, this particular graph, I'm going to erase just that information so I can tell you about maxes and mins without running off of the page. But this particular information also tells me where some maxes and mins are located. Notice that the first derivative changes from positive to negative. That means increasing to decreasing. That means that there's a max at x equals 0. Notice that at 1, the derivative changes from negative to positive. So it's going from decreasing to increasing. That means there's a minimum at x equals 1. So you start with the original equation, you find the derivative, you set the derivative equal to 0, you find those zeros, and you make a number line. The number line helps you figure out where f of x is increasing and decreasing, and it also tells you places where f of x has a max or a min or both. Alright, here's another equation. F of x equals x squared minus 4 to the 2/3. So we're going to start off with finding the derivative, which would be 2/3 times x squared minus 4. Subtract 1, so 2/3 minus 1 would be negative 1/3. And then times 2x because of the derivative of the inside. I'm going to rewrite that a little bit just to make it easier to read. See, we have 2/3 times 2, so that's 4/3. Our x is not to a power, so I'm going to bring it to the top. And then x squared minus 4 is going to go to the bottom to the 1/3. Alright, so I need to find my critical points. It looks like that we have a critical point at 0 because the top is equal to 0 at 0. And then if I set the bottom equal to 0, divide by 3, take the cube root, you get x squared minus 4 equals 0, so you'll get x equals plus or minus 2. So it looks like we've got 3 things to put on our number line. We have negative 2, we have 0, and we have 2. Alright, we go back to the derivative. So we're going to plug in different values into this part up here. So let's say we plugged in a negative 3. Alright, on top you would get a negative. On the bottom, you're going to get negative 3 squared is 9, minus 4 is 5. So on the bottom you would also get positive. Alright, I think I said that wrong. The top is negative because you're plugging in a negative number. The bottom does give you positive, but the top's negative, so it's negative divided by positive. Alright, if I plug in a negative 1, so the top will be negative. The bottom, so negative 1 squared would be positive 1. Positive 1 minus 4 is negative 3. Negative 3 to 1/3 would be a negative number. So it looks like we have a negative over a negative, so we get positive. Plug in a number between 0 and 2, maybe 1. The top will be positive 4. The bottom would be negative again, so we have a negative there. And then plug in a number bigger than 2, maybe 3. The top would be positive. The bottom would also be positive. Alright, so looking at the graph, or at this sign chart here, here's what I know. I know that f of x is increasing from negative 2 to 0 and 2 to 0. I mean 2 to infinity, because that's where f prime of x is positive. I know that f of x is decreasing from negative infinity to negative 2 and also 0 to 2 because the sign chart shows me negative right there. Alright, let's talk about maxes and mins. So maxes and mins are occurring at all of these places. I will tell you that it doesn't always occur at one of these places. It's possible for it not to happen. And I'll show you one of those, or show you a number line of one of those. But it looks like here that there's a minimum because f prime is changing from negative to positive, decreasing to increasing. Here there would be a maximum. F prime is changing from positive to negative. And then here there would be a minimum because it goes from negative to positive. Right now we're just finding the locations. Eventually we'll find those y values, but now we're just finding the locations. Okay, let's look at one more example. Okay, so we have f of x equals x to the fourth plus 1 over x squared. So I'm going to start by finding the derivative, which I need to do the product rule. So the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Alright, I'm probably going to go ahead and factor out an x just because it looks like it would be easier and I can get rid of an x. So when I factor out an x on top, I have 4x to the fourth because I'm getting rid of one of those x's minus, and I'm going to take away this x, so we've got minus x to the fourth minus 1. And if I simplify just a little bit more, I get 3x to the fourth minus 1 over x to the third. And I just realized I made a mistake right here because this 2 has to be multiplied by both of these. So this should be 2x to the fourth minus 2. So then down here we have 2x to the fourth minus 2. Sorry about that confusion. Alright, so we're going to take that derivative, we're going to set it equal to 0 so that we can find our critical points so that we can make our number line. And I'm going to do it on the next page just so I have more room. So I'm going to set the top equal to 0, and then I'm also going to set the bottom equal to 0. I get x equals 0. Add 2 on both sides, divide by 1 or divide by 2, and then take the fourth root. So it looks like that we have 0 and plus or minus 1 to go on our number line. Okay, remember we're plugging things into the first derivative. So I'm going to go back to the first derivative and think about it. This is the thing that I want to plug some things into. 2x to the fourth minus 2. I'll write it over here on this side just so we can kind of look at it in case it helps us instead of having to go back and forth. Okay, so if I plug in a negative 10, bottom's going to be negative, top will be positive, so we have a positive here. If I plug in a number between negative 1 and 0, maybe negative a half, looks like, so a half to the fourth will be a 16th, times 2 will be an eighth. Looks like we're going to get a negative on top. On the bottom, if I plug in negative a half, looks like we're going to get a positive, or another negative, so we get a positive. That's wrong. The top is going to be positive, bottom is going to be, top's going to be negative, bottom's going to be negative, so you get a positive. And if you get confused, we can just plug that in the calculator. Alright, so because this is getting confusing with the negatives and the positive, I'm just going back to the calculator. If I plug in like a negative 10 or negative 3, negative 2, whatever, you do get a negative right here. And all I did is I plugged those values into here in the calculator. Alright, if I plug in a half, I also get a negative number. And you know what? I'm not plugging it into the right value in my calculator, so, okay, I really have it this time. I was plugging in a positive 1/2, and it did give me a negative there, but I need to be plugging in a negative a half, because it's negative 1 to 0, so that should be positive. Alright, and then, if I plug in, like 2, I get a positive. Alright, so here's what we know. Now that we finally got our chart to look the way that it should, we know that f of x is increasing from -1 to 0 and 1 to infinity. We also know that f of x is decreasing from -infinity to -1 and 0 to 1. I can tell that there would be a minimum at x equals -1 and x equals +1 because we're going from negative to positive around it, and that means decreasing to increasing. It looks like there's a maximum at x equals 0 because f of x changes from positive to negative. However, this is a little bit tricky at 0 because 0 was a place where the derivative was undefined. But if you look at the original equation, the original equation is also undefined as 0, meaning there's not a value, there's not a y value at x equals 0. If there was, it would be a maximum, but really there's not a maximum. And that's only because when I plug in 0 into the original equation, it's undefined. There would be a 0 on the bottom. So there's really not a maximum. And if I graph that original graph, it looks kind of like that. Well, over there on the end, it actually goes up a little bit, but it kind of looks like that, where this is an asymptote. So just so you can see the graph. Now, the reason that this is important is because the graph is not always easily accessible, and it's not always easy to graph the equations in the calculator. You can't always see the maximums and the minimums. So we've got to use this process to find all maxes and minimums, and eventually we're going to use this process and do a little bit more to be able to graph an equation completely without a calculator, something that you've not been able to do before. So it's kind of interesting that it can be done, and I just need to show you those processes. So anyway, here we're just finding increasing, decreasing, maxes and mins, and we're using the first derivative to do that.